Hello children, I hope you all are fine at home. I am Mrs. Shagufta Patel. I'll take Science of Standard 10th. Uh, to begin with, let us understand first the two parts of science, Science 1 and Science 2. I'll take Science, today we'll take Science 1, which is basically made up of chemistry and physics, more of physics, less of chemistry. And Science 2 comprises basically of biology as well as environmental science and disaster management and social health. All these issues will be covered in Science 2 section. To begin with today's lesson, I'll take lesson number 2 of Science 1, that is periodic classification of elements. Now, this lesson tells us about the history of classification of elements. As you all have learned in the lower classes, elements are classified into metals, non-metals and metalloids. Okay, and the properties of metals and non-metals you have already learned in the lower classes, so we need not go in detail of all these things. And then metalloids also you know about, that they have properties intermediate between a metal and a non-metal. Now, what we are speaking here is that when the elements were discovered right from the 18th century onwards, okay, scientists have had come forward and they had put, given a method by which we could classify the elements known from that time onwards. Okay, so now here, right from the 18th century, first the elements were less in number discovered. Then later on, as we progressed ahead, more and more elements were discovered. Okay, till now we have around 118 elements known so far. So as the elements were getting discovered, a need was felt to classify them. Okay, and then therefore here we talk about 4 people who came forward. Okay, and then they put forth their classification idea. So here in the lesson we learn about 4 people here. To begin with, okay, the first person who gave us the classification idea was Dobriner, and he put forward his idea of classification. So we will be learning about Dobriner's law of triad in detail. Then after his law was a failure, then came Newland, the second person, English scientist. He put forward his law of octave, which is famous as Newland's law of octaves. And again, once it was a failure, okay, then came the third person, Dmitri Mendeleev. Okay, he did lot of work in the field of classification. He made proper groupings and periods and all. In this way, as elements were discovered more and more later on, okay, you could place them properly in the periodic table. Okay, then lastly, once again Mendeleev's periodic table was a failure. Then came Henry Moseley, the fourth person, okay, who rectified the mistakes committed by all the earlier 3 people, and he then came forward with a new periodic table, which is also called as the modern periodic table, or we also call it as the long form of the periodic table, because it is a big periodic table. Okay, now again we have to understand before we proceed further is that the first 3 people who classified the elements, they took into consideration atomic mass of the element, because they felt that atomic mass is a very important property of an element. But more than atomic mass, okay, Henry Moseley said it is not atomic mass, it is atomic number of the element. Okay, we should be taken into consideration, okay, in classifying the elements. And when he took into consideration atomic number of the elements and classified, he found that what all defects were there in the earlier classification, that all were rectified. Okay, so now to begin with, in the year 1817, Johann Wolfgang Dobriner, he put forward his idea of classification. Okay, he arranged chemically similar elements in groups of 3, and this groups of 3 is called as a triad. So he brought together chemically similar elements in groups of 3 called as a triad. Okay, now in this triad he arranged the elements in the increasing order of the atomic masses, beginning from the lowest to the highest. Okay, so he arranged them in the increasing order of the atomic masses. And once he arranged them in the increasing order of the atomic masses, what he found was that the atomic mass of the middle element in the triad, okay, is the average of the atomic mass of the other 2 elements of the triad. Okay, this is what he found out, and this law is called as Dobriner's law of triad. Okay, so it is a very important and famous law. Okay, because that time in the 18th century very few elements were discovered, so therefore all the elements discovered, majority of the elements discovered in those period, he could give a place to them by this method. Okay, of course every element did not obey his rule, every triad could not be following this method, but a few triads he identified, and he found out that whenever we prepare a triad, whenever we prepare a triad, okay, what is first of all a triad? It is a group of 3 elements, okay, chemically similar elements. So he made a group of 3 chemically similar elements and arranged them in the increasing order of the atomic masses. And once he did that, he found that the atomic mass of the middle element is the mean of the atomic mass of the other 2 elements of the triad. Okay, this is called as his Dobriner's law of triad. Of course, his law was not applicable to all the elements known that time. So to understand the concept in a much better way, I'll show you one small animation.
We all know that matter can exist in the form of elements, compounds, and mixtures. When elements were discovered, a proper classification was required for their easier and better understanding. Many scientists adopted different ways to classify them. They tried to find out some pattern or regularity in the properties of elements. The first among them was Johann Wolfgang Dobereiner, a German scientist who in 1829 found some groups of 3 elements which showed similar properties. These groups are called as Dobereiner triads. Here, if we have a look at triad table, we can see that the atomic mass of the middle element is approximately the mean of the atomic masses of the other 2 elements. As this classification was a primitive step, Dobereiner could identify only some triads from the elements known. Other triads did not obey the rule. Hence, the system of triads was not.
As you could see in the animation that Dobereiner's law of triad could not be applicable to all the elements. So after his law was a failure, then came an English scientist in the year 1866. Okay, he is an English scientist called as Newland, and his law is famous as Newland's law of octaves. And he arranged the elements in the increasing order of the atomic mass. And what he found out, when he arranged the elements in the increasing order of the atomic mass, he found out that every 8th element was having properties similar to the first one. Like how we have an octave of music. Okay, when you see an octave of music, okay, we know, and the Hindi octave of music is sa, re, ga, ma, pa, dha, ni, sa. So the note is repeated again, sa repeated again, sa, re is repeated again. So you find that every 8th note and first note is similar. If you talk about the English octave of music, it is do, re, mi, fa, sol, la, ti, do. So again, the first and the 8th note. Suppose if you're beginning with do, we are ending in do. So the first and the 8th note is similar. Same way he said that the first and the 8th element properties are similar. Okay, so what it does is law state, Newland's law of octave states that when the elements are arranged in the increasing order of the atomic masses, the property of every 8th element is similar to the first element, like an octave of music. Okay, and with this law he could arrange nearly 56 elements known that time, and he could give place to all those elements known that time. His periodic table, though it was a small table as such, not a very big table, but this table began with hydrogen and ended with thorium. So, but again you will see afterwards that his law also could not be applicable to all the elements. There were some limitations and drawbacks. So again, to understand the concept in a better way, I have got a small animation for you to see. So please children, go ahead and see it.
Triads. The next attempt to classify elements was done by British chemist Newlands. By this time, 56 elements were discovered. He arranged all these elements in an increasing order of their atomic masses and found that every 8th element had properties similar to that of the first. He compared this to the octaves found in music, and therefore this classification was known as Newland's octaves. However, this classification had its own share of shortcomings, the main points being that Newland could arrange elements only up to calcium out of the total 56 elements known, after which the elements did not show similar properties. Also later, several new elements which did not feature in Newland's classification were discovered. After the
As you could see in the animation that his law was applicable to some elements, till calcium his law could be applicable. So till calcium the elements behaved in a proper manner, in the sense every 8th element was having properties same to the first element, like an octave of music. Okay, but after calcium the elements did not follow the Newland's law of octave. His law could not be applicable after calcium. And what was the other drawback of his law. What was the other limitation of his arrangement? Sometimes he had fixed two elements in one place. In one box you had placed two elements. If you could see in your periodic table in your textbook, okay, you could see cobalt and nickel are placed together, okay, in one box, and they are placed with very good non-metals above them, halogens. Okay, so now it is a totally mismatch, wrong classification, because we cannot have a metal in the group of a non-metal because they are dissimilar in properties, totally opposite properties they have got. So one drawback was that. So he tried to squeeze elements somehow to fit in one place. And again, if you could see, he had arranged iron. Iron was placed below oxygen and sulfur. Again, it is a wrong classification because again iron is a metal and oxygen and sulfur, they both are non-metals. So therefore there were limitations for Newland's law of octaves also. Just because he could not fulfill the criteria for all the elements, okay, again his law was a failure.